Welcome to InventorCAM Professor. I'm Sydney, your InventorCAM Professor, and in this session we'll be doing a demonstration on HSS high-speed surface machining. HSS is a high-speed surface machining module for smooth and powerful machining localized surface areas in the part, including undercuts. Now what I'd like to do in this particular part is to machine these surfaces over here. Now it should be noted that these surfaces has a gap between them over here and holes on the surface as well. Now normally for me to do something like this, I would have to plug up these areas either by putting another solid here and plugging up these holes in order to do this correctly. But in HSS we have the tools to actually allow us to glide over this area as if this was one whole complete surface. Now I'll start my operation in HSS using the option of parallel cuts, constant Z. In other words, I'll be working on these surfaces here parallel to them in the constant Z fashion on the surface itself. My geometry will be this surface, and this surface as shown here. Notice again, as I've mentioned before, there are gaps between the surfaces plus the holes on the surface itself. Now the next thing I must do is choose my tool, and in the tool area I'll be using a 10mm bullnose tool with a 1mm radius at the corner itself. My levels, I'll leave it exactly the way it is, and now I'll go into my Toolpath Parameters. In my Toolpath Parameters, I have control of my maximum step over, and in this particular case I'll make it every 2mm. In addition, I have my sorting area where I can work zigzag, one way, or spiral, and I'll use the option of zigzag going back and forth. Now let's go into our link. Our link is actually our very important area. Remember I said before that we have these gaps over here and these gaps over here as well. To control that the gaps will actually go directly over the part itself, we have here the area called gaps along cut. If I have large gaps, as shown over here, I can simply say direct. What will actually happen is it'll go directly over the gap as shown in this picture over here from one area to the next. Now in addition, I also have link between slices. That means at the end, how do I want to go from one slice to the next? And if I have a large slice, I also want to do that directly. Now let's take a quick look at our simulation after I do my save and calculate, and you'll see that the toolpath is going directly over the surface itself as if there was one whole complete surface, not jumping over or sinking into those surfaces at all. Now what I'd like to do here as well is I'd like to take the end of my toolpath over here and actually extend it further out so it doesn't stop exactly on the corner here, and the same thing on this side as well. For that we have a tool in our geometry called Extend Trim. All I have to do is simply open up this field and I can give it a value of how much I want it to extend at the start and at the end. And I'll set this value at 20mm so we can actually see it on our screen. And I'll simply say OK. Now when we take a look at our simulation, you'll see that the toolpath now is extending past the surface itself, giving us for a nice smooth finish at the ends as well. Now in this part, what I'd like to do is actually machine these surfaces around over here, and I want to actually machine it parallel to this curve on the edge as shown over here. The other thing I must look out for also as well is that when the tool gets close to the edge, that it does not gouge into these walls itself. For that we have a powerful gouge checking option which is not available in any other program. I'll start my HSS operation and I'll choose the option of parallel to curves. Now when I go to my geometry, I'll be choosing these surfaces as my geometry on the part itself as shown over here, and my edge curve will be this curve around the part over there as shown over here. Now the tool that I will be using will be a 6mm ball end mill, and if I go into my toolpath parameters, I'll be using a maximum step over of every 2mm. In addition, I'll go now into my sorting area, and in my sorting area, last time I used zigzag, but this time I'll use a new option of spiral. What spiral will actually do will give me a spiral cut on the surface as it goes around, as shown in the picture over here. Now, in my link field, I'd like to actually now use my lead in and lead out. So for my first entry, I'll activate my lead in, and for my last exit, I'll activate my lead out. Now, in my default lead in out area, I'd like to have my lead in not tangential, but I'd rather have it vertical tangent arc. In other words, coming in from the top. However, my lead out, that I'd like to actually have it at tangential. Now, when I have it as tangential, though, I don't want it to go exactly on the surface itself. Rather, I'd rather have it pick up from the surface as it's leaving the surface, not to leave a mark. So I'll set my height at 1mm. Now we'll go into our gouge check. You'll note when I have my gouge check, I have 4 different gouge checks that I can actually activate. Now, for example, in my first gouge check, I'll simply say that I want my tool tip, my tool shaft, whenever it goes through my drive surfaces and it sees a gouge on the drive surface itself, I want you to retract the tool along the axis. In other words, in my z-axis. Now, in my second gouge check, I'll make a change on my strategy. First of all, I'll have my tool tip and tool shaft working on my check surfaces. And in this particular case, my check surfaces are these surfaces around the part here. And as for my strategy, I'll have my strategy changed to leaving out gouging points. In other words, to leave the gouging points off, and I'll have my trim tool after the last collision. Now, in addition to this, I like to have stock to leave. How far away do I want to stay from the wall itself? And I'll just set it at 1mm so we can see that very easily. I'll do save and calculate. And if we take a look at our simulation using our top view, and let me just zoom into this corner over here, we'll see that the tool is actually going to go around, as shown over here, but it'll stay exactly 1mm away from the wall itself, not gouging the part at all. Now, in this part we have on our screen, what I'd like to actually do is to machine these fillets around the part itself. Now, this particular part was already machined using a 5-axis machine around, but we still have to complete these fillets. Now, the best way and the proper way to do this would be using actually HSS morphed between 2 curves. In other words, I'll be working on the surface between this shape over here and the bottom shape of this curve itself. I'll start my HSS operation and choose the option of morphed between curves as shown over here. My geometry in this particular case will be my drive surface shown over here, and my start edge will be this contour on top, and my end edge will be my second contour on the bottom itself. Now, the tool that I will be using will be a 6mm ball end mill in this particular case. My levels will stay the same. My toolpath parameters, I'll have my maximum step over at 0.1 to give me a nice smooth finish on the part itself. In addition, my sorting, I'll leave that at zigzag. Now, in my link area, I'll just make one small change over here, and I'll have my large links change to direct. Now, if I do a simple save and calculate, and then simulate the part itself, you'll see that my tool will go down exactly on the fillet, giving for a nice smooth finish on the fillet itself, exactly the way it should be done. Now, in this next part that I have on the screen, I'd like to actually machine these surfaces around here according to the shape of the upper surfaces and towards the shape of the lower surfaces. For that, I'll be using Morphed between surfaces. I prefer Morph between surfaces rather than Morph between curves in this particular case, because it's a lot easier for me to pick the surfaces around the part itself rather than picking each curve individually. So I'll start my operation of HSS, and I'll choose the option, as I said, Morphed between surfaces. Now, my geometry, my drive surface will be this surface over here, these surfaces around the part itself, and my start edge surface, my first start edge surface will be these surfaces on top, and my edge surfaces, I'll be choosing these surfaces here on the bottom. Now, the tool that I will be using will be a 6mm ball and mill. And if I go down now to my Toolpath Parameters, I'll be having a maximum step over of every 3mm, leaving it as zigzag. Now, in my link area, I'll be using this time my lead in and my lead out. And in my link between slices, I'll just simply change my large moves to direct. Now, in my default lead in, I'll have my lead in itself as a vertical tangent, but my lead out, I'll change that to a regular tangential arc. Now, when I do save and calculate and simulate the part, you'll see that my toolpath is going down on the part itself, gradually starting from this shape and changing to the shape that we have according to the bottom surface, giving for a nice, perfect, smooth finish on that surface itself. You'll also note that my lead in is exactly the way I had mentioned it, in a vertical, whereas my lead out is going out in a tangential shape. Now, in this next part that we have on our screen, I'd like to machine these surfaces around over here. Now, you'll note that when I do that, I have a little gap between this area and this area over here, and I'll be actually causing it just to go directly from one area to the next. What I'll do is I'll start my operation in HSS. I'll use the option right now of parallel cuts, constant Z. My geometry, I'll start off with my geometry choosing this surface and this surface only. I just want to work right now only on these two surfaces, and I'll simply say OK. The tool that I will be using will be a 6mm ball and mill, and in my Toolpath Parameters, I'll change my maximum step over to 0.5mm, leaving my sorting area as zigzag. Now, in my link, I'll be using my lead in and my lead out, and in my link between slices, I'll have that go directly from one slice to the next. Now, let's just do a quick save and calculate, and then run my simulation. You'll see that my toolpath is working exactly on that surface that I had chosen. Now, what I'd like to do now, though, is, however, is to have a continuation working onto these surfaces as well. So what I'll do is very simple. I'll go back to my geometry, and I will continue on picking this surface and this surface as well. Now you see we have 4 surfaces over here. Now, one other change I'll make is I'll simply go into my link area, and now since I have a gap between this area over here, between this surface and that, I just say gaps along cuts in my large gaps as direct, causing it to go directly from one surface to the next. Now when I do save and calculate and simulate my part, you'll see that my toolpath will go exactly on the surface, and when it gets to this area over here, simply goes directly across to the next side itself without jumping up, finishing it exactly the way I had wanted to, with my lead in and lead out in the exact same way I had planned it to do. Now in this last part, I like to demonstrate how we deal with undercuts. Now if you take a look at this part, you notice that this surface over here is actually undercut from this wall over here. And the only way that we can do this correctly would be using HSS. And we'll start our operation of HSS, and in this particular case I'll use the option of morphed between curves. The geometry that I'll be using will be this surface over here, including the surface that's going underneath the part itself all the way across over here. And my start edge will be the first contour on this side over here, and my end edge curve will be the curve that's exactly opposite that curve on the other side. Now the tool that I will be using must be a tool that is actually capable of going in that undercut area. This tool is actually a lollipop tool, which will allow me to actually go underneath that undercut area. Now the toolpath parameters, I'll have my maximum step over at 0.2 millimeters, and I'll leave my sorting at zigzag. Now in my link area, I'll be using a lead in and my lead out, and I'll change my link between slices to direct. In my default lead in and out, I'll change my lead in to be vertical, and I'll leave my lead out to be the same as my lead in. Now I'll do save and calculate and then simulate the part. You'll see that my toolpath is actually going around underneath that area, and as you can see it curves out, showing that my tool is actually doing a nice undercut pass on that surface the way it should be done. Thank you for joining us on InventorCAM Professor on our demonstration of HSS. HSS is the high-speed surface machining module for smooth and powerful machining of localized surface areas in the part including undercuts.